From our perspective here on Earth, the universe can seem like a place of serene stability. The stars follow predictable paths, and the laws of physics appear constant and reliable. This creates a profound, if illusory, sense of safety. But is this truly safety, or merely ignorance born from a limited, local viewpoint? The wider reality is that the universe is fundamentally indifferent, impersonal, and often cataclysmically violent. The very same physical laws that allow a star to warm a planet, that govern the formation of worlds, and that permit the complex chemistry of life, are the same laws that enable its absolute destruction. The universe does not act with malice or intent. Its hostility is far more terrifying because it is fundamental, an inherent property of existence itself. Today, we'll explore ways the universe is fundamentally hostile to life. These are not speculative fantasies from the pages of science fiction. They are dangers grounded in direct observation, confirmed by rigorous physics, and waiting in the silent, patient darkness. Fine-tuning and heat death. First, consider the beginning. On the grandest scales, the laws of physics themselves seem set up to doom life before it can even start. Physicists have noted that the universe's fundamental constants, the strength of gravity, the force of electromagnetism, the mass of elementary particles, are exquisitely and precariously fine-tuned. The underlying principle is that even infinitesimal changes to these values would render a universe where atoms, stars, or chemistry could not exist. If the constants governing nuclear forces were altered, atoms beyond hydrogen might not be stable. Existence in this sense is a cosmic narrow escape. The horror here is existential. The threat is the overwhelming probability that any universe would have laws that forbid the existence of complexity. So why is our universe different? Life is only possible on the razor's edge of cosmic parameters. We are not just fighting against dangers within the universe. Our very existence is a fight against the universe's default, sterile state. But this is only the first jaw of the trap. Even given a life-friendly universe, one that beats the astronomical odds of fine-tuning, the second law of thermodynamics dooms everything to an eventual heat death. The current lambda CDM model of cosmology, supported by observations of cosmic acceleration, predicts an endless expansion. Over unimaginable timescales, this expansion will lead the universe to a state of maximum entropy and near absolute zero temperature. The leading cosmological models detail this final, bleak chapter. After approximately 100 trillion years, star formation will cease as all available gas is used up. The existing stars will burn out and die. Ultimately, only black holes and other degenerate remnants will remain, and even they will evaporate over googles of years via Hawking radiation. The universe will become a dark, dilute expanse. There will be no energy gradients, no heat sources, and no flow of usable energy to sustain any process, let alone life. In the end, life becomes impossible by any known measure. This is the ultimate trap. The universe's own operating system is the final threat. Its initial conditions make life an almost impossible miracle, and its ultimate fate guarantees that even this miracle will be extinguished without a trace. The anthropic paradox is that our universe's parameters are just right to allow for a rare island of order in an otherwise chaotic landscape, but there is no escape clause. Those same laws guarantee death. Life is an ephemeral fluke, an impossibly lucky and temporary spark carved out of a universe that is fundamentally and finally destined for an eternity of cold, dark, and featureless emptiness. Rogue black holes. These are the collapsed remnants of massive stars, and through the chaotic dynamics of star clusters and supernova explosions, many are ejected from their birthplaces to wander the galaxy alone. They are undetectable unless they are actively feeding on infalling matter. Should one of these silent wanderers pass through a solar system, it would bring a unique and methodical form of destruction. The threat is not one of simple collision, but of gravity itself being weaponized through the power of tidal forces. A planet is a large object, and a black hole's gravitational pull on the near side of that planet will be immensely stronger than its pull on the far side. This differential, this extreme gravity gradient, begins to stretch the world. Astronomers have a clinical, yet deeply horrifying term for this process: spaghettification. The planet would be pulled and stretched, its solid crust cracking, its molten core deforming and elongating. It would be drawn out into a cosmic ribbon, a long, thin stream of atoms flowing inexorably towards the black hole's event horizon. An unseen predator, silent and dark, stretches your world into oblivion. There is no fire, no radiation, just a slow, silent, and complete destruction. This is not a theoretical exercise. Astronomers have witnessed these events across the cosmos. They are called tidal disruption events, or TDEs, and TDEs are well-documented phenomena where stars are torn to pieces by black holes. Indeed, when this happens, the resulting flare of energy from the devoured star can temporarily outshine the entire host galaxy. But the mechanism that devours stars is the same one that would devour a planet, suggesting a common end for anything that wanders too close. For example, a famous Hubble observation captured a star being stretched like taffy as it was torn apart by a black hole with a mass of about 1 million suns. A similar fate would undoubtedly await any planet that wandered too close. NASA has even created animations of TDEs, showing a star being drawn in, stretched, and consumed in an energetic burst, a process they fittingly describe as cosmic cannibalism, the Galactic Core. At the heart of the Milky Way, and nearly every other large galaxy, lurks a monster of incomprehensible scale, a supermassive black hole. Our own Sagittarius A star has a mass of over 4 million suns. For now, it is relatively quiet, but it has the potential to ignite into one of the most destructive engines in the universe. When a supermassive black hole begins to actively feed on a large supply of gas, dust, and stars, it can flare into an active galactic nucleus, or AGN. In this state, it can become one of the most luminous objects in the cosmos, unleashing vast jets of plasma and radiation that dwarf entire star systems. We have seen this happen in other galaxies. We can see this in NASA observations, specifically Hubble's iconic image of the galaxy M87, which shows an active galactic nucleus jet of plasma erupting from its central black hole. This beam stretches for tens of millions of light years. This is not a benign celestial light show. Recent studies indicate that these active galactic nuclei and quasar outbursts can have devastating consequences for life across a galaxy. A study by astrophysicists John Forbes and Abraham Loeb calculated that a powerful quasar outburst would be capable of blowing off the planetary atmospheres of worlds over enormous distances. Their calculations showed that roughly half of all planets in a galaxy would lose at least a Mars-sized atmosphere. A few percent would lose even Earth-like oceans, effectively sterilizing them. In short, the center of our galaxy could become a malevolent sun. If Sagittarius A star were to ever flare into a powerful active galactic nucleus, its jets and radiation could fry habitable worlds throughout the inner regions of the galaxy. This very real danger has led to the development of the Galactic Habitable Zone concept. This is not just a region with enough heavy elements for planets, but one that is also safely distant from the galaxy's violent core. The concept itself serves as an implicit warning, explicitly excluding the central regions, partly because of these potential active galactic nucleus hazards. Earth and life here survive only because of our lucky location in the galactic suburbs, far from a downtown core that could, at any time, erupt in a sterilizing blaze. Rogue planets. This threat is not one of annihilation, but of eternal exile. It is the fate of a planet cast out from its home system, ejected to wander the cold, dark void alone for eternity. This is the lonely fate of the hypervelocity, or rogue planet. The early eras of star systems are often a time of intense gravitational chaos. Interactions between newly formed planets or close flybys of other stars can create highly unstable orbits. In this cosmic game of gravitational billiards, planets can be violently ejected, flung out of their systems, and into the vast, empty expanse of interstellar space. They become the orphan worlds of the galaxy, and their numbers are staggering. Theoretical models predict that billions of such orphan worlds likely exist in our Milky Way alone. In recent years, astronomers have begun to confirm these predictions. They have detected massive rogue planets like PSOJ 318.522, a world with the mass of Jupiter. Even more compellingly, in 2023, a study published in Nature Astronomy announced the potential discovery of an Earth mass candidate through microlensing. A planet with a mass between that of Earth and Mars was found unbound, freely floating in the galaxy. For any life that might have arisen on such a world, the moment of ejection is an apocalypse of instantaneous and absolute finality. The parent star, the source of all warmth, light and energy, would vanish from the sky in a moment. Within days or weeks, the surface temperature would plummet towards absolute zero. Any atmosphere, if it existed, would freeze solid and collapse to the ground. The world would be plunged into an eternal, frigid darkness. The horror is one of profound isolation and cold. A living world, once bathed in sunlight, is violently and irrevocably turned into a dead, frozen bullet, hurtling silently through the dark space between stars. It becomes a lonely, wandering tomb, carrying the fossilized remains of its biosphere on a never-ending journey into oblivion. Life is cut off from sunlight, and long-term survival becomes impossible without a new heat source, a new star to be captured by, an event of infinitesimal probability. It is a world sentenced to an eternity of darkness and cold. Runaway greenhouse effect. We return to an intimate and absolutely certain doom. It is a threat that requires no external cataclysm, no rogue object, no explosion. It is a slow, creeping execution delivered by the very star that once nurtured life into being. This is the star's inevitable betrayal, a death by runaway greenhouse effect. All main sequence stars, our Sun included, are governed by the physics of nuclear fusion. As they burn through their hydrogen fuel, they grow hotter and more luminous over time. The process is slow but relentless. Models of stellar physics predict that Sun-like stars brighten by as much as 10% every billion years. Our own Sun is already approximately 30% more luminous than it was at its birth. This gradual brightening has a direct and fatal consequence for any planets in the star's habitable zone. The habitable zone, the orbital region where liquid water can exist, is not static. As the star brightens, this zone slowly migrates outward. A planet like Earth, once perfectly positioned, will eventually find itself on the inner, hotter edge of this zone. That is when the betrayal is complete. The increased solar heating will accelerate the evaporation of the planet's oceans. This pumps more water vapor, a powerful greenhouse gas, into the atmosphere. The thicker blanket of water vapor traps more heat, which in turn causes the oceans to evaporate even faster. This creates a positive feedback loop, a point of no return. This is the runaway greenhouse effect. Researchers at the University of Washington have calculated a timeline for Earth's demise. Their simulations show that our world will cross this inner edge and enter a runaway greenhouse state in approximately 1.5 billion years. The oceans will boil away, and the planet will be transformed into a hot, glowing, and utterly sterile version of Venus. Indeed, Venus itself stands as a silent monument to this very process, a proof in our own solar system of what happens when a world loses this battle with its star. There is no catastrophe to fight, no monster to flee. It is a slow, relentless baking. The very star that made life possible, that warmed the primordial oceans and powered the biosphere, will patiently and inevitably warm the world until all life is incinerated. Stellar superflares. Let us now consider a betrayal from the most familiar of celestial objects, a star, much like our own Sun. Imagine this star, the giver of life and warmth to a nearby world, suddenly erupting in a titanic magnetic superflare. This is not a hypothetical scenario. According to data from NASA's Kepler mission, which observed thousands of stars for years, such events are shockingly common. The mission catalogued nearly 3,000 superflares on Sun-like stars, revealing a rate of roughly 1 per star per century. These are not ordinary flares. These flares can be 100 to 10,000 times more energetic than the largest solar flares ever recorded from our Sun. A blast of this magnitude would unleash a torrent of intense radiation and high-energy charged particles, flooding the upper atmosphere of any nearby planet. The sheer energy injection would heat the atmospheric gas, ionizing it and accelerating it past the planet's escape velocity. Simulations conducted by astrobiologists suggest the consequences would be catastrophic. A single global superflare could dramatically erode or, in a worst-case scenario, completely strip away a planet's entire atmosphere. This atmospheric loss could happen in a matter of hours. The horror of this event lies in its profound silence. There would be no deafening sonic boom, no world-scorching fireball consuming the sky. a life-bearing world's air could, in a cosmic instant, be ripped off into space. The sky would fall silent as the air itself vanished, and all respiration on the planet would grind to a halt. This threat is not just theoretical. The Kepler data are unambiguous. Sun-like stars regularly unleash superflares, with energies thousands of times more powerful than anything we consider typical. Astrobiology models confirm the mechanism of atmospheric loss, where the upper layers of a planet's air are heated and blown off into the void. This is further corroborated by direct observations of younger, more volatile dwarf stars. Their frequent and extreme flares are known to be capable of eroding the atmospheres of the planets that orbit them. The final chilling image is one of silent suffocation. There is no impact, no fireball. Instead, the sky would simply go black as the essential blanket of air is torn away, leaving the world a barren, airless vacuum. It is a swift, silent and absolute execution, delivered by the very star that once made life possible. Dense interstellar clouds. If a star's betrayal is a slow death by fire, our next threat is an equally slow death by ice and shadow. It is a silent, insidious danger that comes not from a celestial body, but from the seemingly empty space between them. This is death by cosmic fog, a passage through a dense interstellar cloud. Our solar system is not stationary. It drifts through the galaxy on a long, slow orbit, and in doing so, it occasionally encounters dense interstellar clouds of gas and dust. Evidence suggests that such an encounter happened in our own recent past. Between 2 and 3 million years ago, the Sun and its planets plunged into just such a cosmic fog. This is not speculation. Geologists have found concrete evidence in the form of specific cosmogenic isotopes, namely plutonium-244 and iron-60, embedded in Earth's crust and Antarctic ice cores. These isotopes date precisely to that era and are known to be forged in supernovae, meaning they must have been deposited from the interstellar medium. Astrophysicists using data from the European Space Agency's Gaia mission have modeled what this event would have looked like. Our Sun generates a protective bubble of plasma and magnetic fields called the heliosphere, which shields the planets from the harsh environment of interstellar space. Their models show that this dense cloud would have compressed the heliosphere to a fraction of its size, shrinking it to just 0.2 astronomical units, barely beyond the orbit of Mercury. This collapse would have left Earth directly exposed to the intense flux of galactic cosmic rays. The consequences are chilling. First, the bombardment by cosmic rays would dramatically alter the climate. Second, the dense cloud itself would act like a shroud, dimming the light from the Sun and reducing the energy reaching Earth's surface. The combined effect could easily trigger a prolonged global cooling or a full-blown ice age. There is no flash of light, no violent impact. It is a gradual extinction, a creeping freeze rather than a sudden blast. It is a world slowly suffocating as it drifts through a cosmic fog, the stars dimming behind an encroaching darkness as the planet is plunged into a long, deep cold. In conclusion, our planet is not a fortress. It is a lifeboat adrift on a cosmic ocean, built from the same forces that create the storm. And so, we are left with the ultimate, unsettling question. How long can this fragile island of order last in a universe that is magnificent in its power and utterly indifferent to our survival?